Hello guys, let's solve this integral right here, and I will give you guys the hint to know your multiples. 2. Well, this 2 is not part 2, but it's just a second method. So if you want to know the first method, watch my previous video over here, and let's start with the multiple angle formulas. First, for is sine 2x, which is 2 sine x cos x. Now, we're going to be using this over here somewhere, maybe not in the first step, but we'll definitely use it. And as a bonus, I'll also give you guys the multiple angle formula for cos 2x because it will come quite frequently and you guys will need it. So this is this. And also, in most cases, you will not really have to use cos square x minus sine square x. What you'll in fact have to use is either 2 cos square x minus 1 or 1 minus 2 sine square x. Because here, if you have to solve the integral for sine square x or cos square x, well, you can just go to the cos 2x multiple angle formula and then solve it from there. And now let's focus on our main integral. So, we have our sine 2x on the top. I really don't want to put down this formula over here yet because I don't know where it will lead us to. But we have sine x plus cos x whole square. Let's just expand that. So this will be sine square x plus 2 sine x cos x plus cos square x and dx. Now, you can see we have 2 sine x cos x, which is just our sine 2x. But another interesting thing about sine x plus cos x whole square is we'll have sine square x plus cos square x, which is just 1. So that means on the top we have sine 2x, and on the bottom we have from these two 1, and this is just sine 2x. And to solve these types of integrals, just add the constant, subtract the constant, or subtract the constant and add the constant. Do not change the integral, of course. So, we'll then have to split this into two fractions. First, this fraction minus that fraction, or the integral, right? So, we'll have first 1 plus sine 2x by 1 plus sine 2x, which will just give us in the integration of dx, minus, and we'll just have 1 by 1 plus sine 2x dx. Now, integration of this is just x minus. Now, this is the second method, so what we're going to do is we look at 1 plus sine 2x and we see where it came from. Well, it came from here, right? And we already did this in the first method. So, let's go one step back. So, this will be 1 by sine x plus cos x whole square. Now what do we do from here? That is the main question. So, what we're going to have to do for these types of integrals is multiplying the numerator and denominator by sec square x. I know this might seem a very random thing to multiply it with, but it kind of works out because here sec square x dx, well, if you have tangent, its derivative will just be sec square, right? So, if you have tan x somewhere in the denominator or even maybe in the numerator, differentiate that, you'll get sec square x dx in terms of, let's say, du, dy, dz, whatever you have let your variable to be, and then you can proceed from there. So, let me show you what I mean. First, in the above we'll have sec square x dx. Now, what will we have in the bottom? So, it's just a simple indices method. Sin x plus cos x whole square. This is to the power of 2. Sec square x, this is also to the power of 2. So we'll just have sin x plus cos x into sec x whole square, namely this. And let's just multiply it out. So sin x into sec x. Well, sec x is just 1 by cos x. So first we'll have tan x. And cos x into sec x, well, they're just reciprocals of each other, namely sec x is just 1 by cos x, as I said. So this is just 1, this will be just whole square, right? So that means we'll just have 1 plus tan x whole square on the bottom. Now I told you that if we had tan x, we can substitute that in and we'll get du or whatever in the numerator, and we can proceed from there. So what you can do is you can let u equals to tan x and then du will be equals to sec square x dx. And you can proceed from there. You'll have 1 plus u whole square and you're going to have to use the power rule. But what you can also do is just simply let u equals to 1 plus tan x. Because here, what you'll end up getting is, well, you'll have, well, x minus integration of du by u square. I mean, yeah, just the power rule, right? So this is just u to the power minus 2 integration. So when you integrate that, you'll have to add the power to that, and whatever the new power is divided by that. So minus 2 plus 1 is equals to minus 1, over here also minus 1. So you have x minus u to the power minus 1, which is 1 by u into minus 1. Well, we have minus minus, which is plus, and our u is simply just 1 plus tan x, and don't forget our plus c, and that is it. We have solved our integral right there. And if you learned something new, please like and subscribe. Thank you.